The Norwegian fjords. The darkness comes early in Norway. Long before the sun gives up on the horizon, the water turns black and the cold descends like a physical weight, pressing down on the surface of the fjords with a silence that feels almost sacred. In winter, the air temperature can plummet to -15 degrees Celsius, and the spray that blows off the wave crest freezes before it falls back to the sea. But beneath that surface, beneath the cold, beneath the dark, something extraordinary is about to begin. Every autumn, as the water temperature drops across the North Atlantic, one of the greatest gatherings in the natural world quietly sets itself in motion. Billions, not millions. Billions of Atlantic herring Clupea harengus begin their migration southward along the Norwegian coast, funneled into the deep-cut fjords by a combination of instinct, cold, and hunger. These slender, silver fish, rarely longer than a human forearm, travel in formations so dense that sonar equipment reads them as solid ground. A single school can stretch for kilometers in every direction, shimmering beneath the surface like a living, breathing galaxy. The reason they come here is the Gulf Stream, that vast ribbon of warm water, pushed north by Atlantic currents all the way from the tropics, keeps the inner Norwegian fjords from freezing completely in winter. It creates a thermal refuge, a place where the water, though cold by any human standard, remains just warm enough to sustain the herring's metabolism through the long, lightless months. For the herring, these fjords are safety, a hiding place. They crowd together in the deep channels, waiting for spring, burning as little energy as possible, holding still in the dark. But nothing that glitters silver is truly hidden. The orcas know. They have always known. Orcinus orca, the killer whale, is among the most cognitively sophisticated predators on this planet. These animals carry knowledge not just in their instincts but in their memories, passed down through generations in family groups called pods. The Norwegian fjord population has been returning to this coastline for decades, perhaps centuries. They know the shape of the water here. They know the depth of the channels, the angle of the rocky walls, the behavior of their prey. They arrive in November, sometimes in October, following a calendar written in their blood. When you see them first, they look almost leisurely. A pod of 5, perhaps 7 animals, moving in loose formation across the gray surface of the fjord. The tall, knife-straight, dorsal fins of the moths cut the water cleanly, some of those fins reaching nearly 2 meters in height, an unmistakable silhouette against the pale winter sky. The females are smaller but no less impressive. Their movements are deliberate, unhurried, with the calm confidence of animals that have nothing to fear from the world around them. And why would they fear anything? In these waters, the orca has no predator. Nothing in the Norwegian fjords outthinks them, outswims them, or outstrategizes them. They are at the absolute pinnacle of a food chain that reaches from microscopic plankton all the way up to them. Their only competition is each other, and even that is managed by the complex social protocols of pod life. Below the surface, where the light barely reaches in December, the herring sense the disturbance before they can see it. A change in pressure, a shift in the water, the faint, low-frequency clicks and calls of orcas moving in formation. For a fish with no way to defend itself beyond numbers, the instinct is immediate and primal. Compress, tighten, pull the school together until the individuals dissolve into a single enormous mass. This is exactly what the orcas are counting on. The fjord at night is not quiet. Beneath the silence of the surface, there is a constant underwater world of sound. The high-pitched whistles of orca communication, the clicking sonar of their echolocation sweeping through the water like searchlights, the low rhythmic rush of their flukes pushing them forward. The herring, packed together by the billions into a ball of silver in panic, do not know that their instinct for survival is also their greatest vulnerability. By coming together, they have made themselves into exactly the kind of target that orcas have evolved over millions of years to exploit. The water is cold, the sky is dark, the fjords are waiting, and in the deepest channels, where the rock walls plunge hundreds of meters to a silted floor, the greatest underwater hunt in the Northern Hemisphere is about to begin. The orcas circle, the herring compress, and somewhere in the darkness, the balance between hunter and hunted shifts, just barely, just enough, toward the predator. The chase, when it comes, will be spectacular. But first, there is the gathering, the preparation, the slow, methodical tightening of a trap that the prey cannot see and cannot escape. This is the Norwegian fjord in winter. This is where giants feed. Part 2, the hunt begins. Watch the dorsal fins. That is the first lesson of anyone who has spent time in these waters. When the fins begin to move with purpose, when they angle inward, when the lazy arcs of surface breath become shorter and more frequent, when two animals that were 20 meters apart are suddenly 10, the hunt has already begun. The orcas have found their target. Deep below the surface, in the dark, cold water, a school of herring the size of a city block is about to face the most efficient predators the ocean has ever produced. The strategy the Norwegian orcas use is not brute force. It is architecture. They are building something, an invisible structure made of movement, sound, and light, designed to bend the behavior of the herring to their will. It begins with what researchers call carousel feeding, a technique so sophisticated that it was not fully understood by scientists until they began placing cameras and hydrophones directly inside the schools themselves. The pod splits into roles. Some orcas drive from below and behind, pushing the school upward toward the surface. Others flank the school on both sides, preventing escape to the left or right. The herring, reacting to each new pressure point, compress further and further into a tighter formation. As they compress, something remarkable happens to the school itself. The individual fish lose their ability to break free from the mass. The density becomes so extreme, thousands of bodies packed into a space that should hold hundreds, that the aerodynamics of the school change. It begins to move as a single organism, sluggish and massive, trapped by its own survival response. The orcas push the school upward. This is the critical moment. As the herring rise toward the surface, they lose one dimension of escape. Above them is air. Below them are orcas. On every side, more orcas. The ball of fish is now meters wide, a spinning, flashing mass of silver bodies catching what little light filters down from the overcast Norwegian sky. If you were to hover above the water at this moment and look down, you would see the school as a dark, shimmering shadow just beneath the surface, and around it, the sleek black and white shapes of the orcas in perfect formation. Then comes the tail strike. An orca pulls ahead of the school, dives sharply, curves its enormous body in a wide arc, and returns toward the school at speed, not head first but sideways, rotating in the water, bringing that massive tail fluke around in a swing that connects with the edge of the school like a horizontal axe. The strike is not intended to kill. It is not a bite. The shock wave from a single tail strike travels through water at nearly 1,500 meters per second, far faster than sound travels through air, and it is this concussion that does the work. Herring within a meter of the strike are stunned instantly, their nervous systems momentarily overwhelmed by the hydraulic force. They drift. They stop moving. They hang in the water, limp and silver, completely vulnerable, and the orcas collect them. One by one, with extraordinary precision, they move through the aftermath of the strike, plucking individual herring from the water, with a delicacy that seems almost absurd given the violence of what just preceded it. A jaw that could crush a seal gently cups a herring and tilts it headfirst to swallow. There is almost no wasted motion. Each fish is taken cleanly. A single adult orca needs roughly 227 kilograms of food per day. In these fjords, during the winter herring season, that requirement is met and often exceeded. But the orcas are not greedy in the way that word implies recklessness. They are efficient. They rotate through the tail strikes. One animal strikes while others hold the perimeter. Then they swap. Each individual feeds while the school stays compressed. It is a system that maximizes output while minimizing energy expenditure. A masterpiece of collaborative hunting. Younger orcas learn by watching. A calf born into a Norwegian pod will spend the first years of its life circling the outside of hunts, observing the movements of adults, internalizing the geometry of carousel feeding. It will not attempt a tail strike until it has the body size and coordination to execute it properly. The knowledge is not genetic, it is cultural. transmitted through attention and practice, the same way a young surgeon learns from watching a senior one work. This is not metaphor. This is the reality of orca cognition. The herring that survive a single strike have only seconds to reform before the next strike comes. The school cannot rest. It cannot disperse. The orcas will not allow it. For hours, sometimes for the entire length of a winter night, the carousel continues, tail strikes landing at irregular intervals to prevent the herring from adapting. The fjord's surface periodically erupting in white water and silver chaos as another wave of stunned fish rises to the top. The cold means nothing to the orcas. The dark means nothing to them. They navigate by sound, by memory, by accumulated knowledge passed through generations. They are perfectly built for this moment, in this water, against this prey. Part 3. Giants join the feast. The orcas smell them before they see them. Not through their noses. Cetaceans breathe through their blowholes, surrendered the sense of smell long ago to the demands of aquatic life. But through their sonar, through the low-frequency pressure waves that travel extraordinary distances through cold water, the orcas sense something massive approaching from the open sea, something large enough to displace water in quantities that register not as a signal, but as a feeling. A change in the fjord itself, as if the water has grown heavier. Humpback whales, Megaptera novae angliae, animals that can reach 15 meters in length and weigh 40 tons. Animals with pectoral fins, those extraordinary knobbly white flippers that stretch nearly 5 meters from shoulder to tip, longer than the wingspan of many aircraft. They come to the Norwegian fjords in winter for exactly the same reason as the orcas, the herring. And when they arrive, everything about the scale of the feast changes. Humpbacks are not the hunters that orcas are. They do not strategize in the same way. They do not run carousel formations or coordinate tail strikes with surgical precision. What they possess instead is sometimes and a set of adaptations so perfectly suited to exploiting dense, compact prey schools that they border on the miraculous. Watch a humpback approach a herring ball. It does not come from the swim. It does not come from above. It comes from below, and it comes fast. The animal drops deep, often 30 to 50 meters beneath the school, then rotates so that its enormous white belly faces upward. What happens next takes less than 3 seconds, but those 3 seconds represent one of the most powerful feeding events in the ocean. The humpback surges upward. Its body accelerates through the water at a speed that seems impossible for something of its size, the massive tail driving it with a force that generates bow waves visible at the surface. As it rises, its jaws begin to open. Those jaws, which in a large adult male can spread to an angle of almost 90 degrees, create an opening roughly the size of a small car. The herring, already compressed by the orca carousel above them, have nowhere to go. The whale breaches the surface in an explosion of white water and silver fish, its mouth a gaping cavern filled with thousands of herring and hundreds of tons of seawater. The filtering happens in seconds. The humpback's lower jaw drops further, and the massive pouch of expanded throat skin, the ventral pleats, which can expand to hold the equivalent of a small swimming pool, contracts, forcing the water out through the baleen plates that line the upper jaw. The baleen, made of the same keratin as human fingernails, forms a dense curtain of interlocking fibers that trap the herring while letting the seawater rush back into the sea. What remains is approximately 100 kilograms of stunned, trapped herring, which the whale swallows in a single muscular contraction of its throat. 100 kilograms, in a single gulp, in less than 5 seconds from approach to swallow. The orcas watch this with what can only be described as calculated indifference. They have seen the humpbacks before. They will see them again. The relationship between the two species in the Norwegian fjords is not one of competition in the simple sense. The orcas create the herring balls. The humpbacks exploit them. In a strange way, the orcas are inadvertently feeding the humpbacks. Their hunting technique produces prey in a form that the larger whales are perfectly equipped to harvest. But the humpbacks are not passive beneficiaries. They bring their own contribution to the fjord ecosystem. Their vast bodies, moving through the water, churn nutrients from the deep. Their exhalations, those towering columns of warm, moisture-laden breath, visible for hundreds of meters on cold mornings, are themselves a form of fertilization, returning nitrogen to the surface layers where phytoplankton grow. In ways that are only beginning to be understood by science, the presence of great whales in these waters makes them more productive, more alive, more capable of sustaining the very prey that the whales depend on. Watching a humpback breach in the Norwegian fjords in winter is one of the defining experiences of the natural world. The sheer physical drama of it, a 40-ton animal rising entirely clear of the water, its white belly catching the pale winter light, crashing back with a sound like a cannon shot that echoes off the granite walls for seconds, is almost too large to process. But beneath the spectacle is pure function. Every element of that breach, from the angle of approach to the timing of the jaw, has been honed over 47 million years of evolutionary refinement. The humpback is not showing off. It is simply being, completely and efficiently, what it is. In the fjord, on a winter day when the light lasts perhaps 4 hours, these two species, the precise, intelligent orca and the titanic, powerful humpback, share the water in uneasy, productive proximity. The herring caught between them have no good options. Below them, the vast mouth of a whale. Around them, the orchestrated strikes of the smartest hunters in the sea. Part 4, the Faulland strategy. She has been watching the tide for days, not with the passive patience of an animal waiting for luck to change, but with the active, calculating attention of a mind that understands time. She knows this coastline. She knows the rhythm of the water, the way it rises each morning and retreats each afternoon, the narrow gap in the rocks where, for a few brief hours every day, the sea floods a shallow pool behind a natural barrier of volcanic stone. She has done this before. She will do it again. And today, she has brought her cub. The Falkland Islands sit in the South Atlantic like a scattered handful of rock and wind, 8,000 kilometers from the Norwegian fjords, a world away from the blue darkness of the Arctic winter. Here the light is harsh, the wind unrelenting, and the coastline jagged with the kind of ancient geology that does not care about the creatures that live on its edges. The beaches are littered with wildlife, albatross, penguins, sea lions in their hundreds, and elephant seals. Southern elephant seals, Moronga leonina, the largest seals on Earth, animals that can exceed 3,000 kilograms in adult males. They haul out on these beaches to breed, to molt, to rest, their vast, blubber-laden bodies arranged along the shoreline like enormous sleeping sausages. But it is not the adults that interest this orca. It is the pups. Southern elephant seal pups are born helpless. Large by any standard, they can weigh 40 kilograms at birth, but utterly without experience. The mothers nurse them for approximately 3 weeks, during which the pups more than triple their body weight on milk so rich in fat that it has the consistency of cream. Then the mothers leave. The weaned pups, suddenly alone, spend the next weeks learning to swim in the shallow waters near shore, practicing in the protected pools that form behind rocky barriers at high tide. These pools are their classroom, and for a few weeks each year, they are the most dangerous place a seal pup can be. The female orca has found the gap in the rocks. It is narrow, barely wide enough for an animal of her size to pass through without scraping the walls on both sides. She is not small. An adult female killer whale averages 6 to 7 meters in length and can weigh 5,000 kilograms. Entering that passage requires not just the physical ability to fit through, but the courage and precision to attempt it in the first place. The rocks on either side show the marks of previous visits. She has done this before. She moves slowly, carefully, her enormous body negotiating the channel with a control that seems to belong to a much smaller creature. Her cub follows behind her, watching everything. This is not just a hunt. This is education. The young orca is learning the passage, learning the technique, absorbing the geography of this coastline into the same deep memory that will guide its own hunts decades from now. Inside the pool, the seal pups react with curiosity. This is the most heartbreaking element of what is about to happen. They have never seen an orca. They have never learned to fear the black and white shape moving through their water. Their mother is gone. Their education in predators has not yet begun. They approach the vast shadow moving toward them with the innocent interest of animals that do not yet know what death looks like. If you are watching this and feel the pull to keep watching, to understand more about these extraordinary animals and the worlds they inhabit, then subscribe now and turn on notifications, because every week brings another chapter of the ocean's most astonishing stories. One pup comes too close. The female orca moves with sudden, absolute precision. No wasted motion, no hesitation, no drama. One moment the pup is swimming, the next it is not. She carries it carefully back through the gap, out through the narrow passage, into the open water beyond. Her cub follows. In the open sea, she shares the catch with her young one. It is not cruelty, it is life. The orca is teaching her cub to hunt in this specific way, in this specific place, using this specific technique. She may have developed this strategy herself, a genuine innovation, an individual discovery, or she may have learned it from her own mother, who learned it from hers. In either case, what we are witnessing is not mere instinct, it is knowledge, it is culture, it is the transmission of a learned skill across generations in a species that lives as long as humans, that forms bonds as deep as families, and that navigates the world with an intelligence we are only beginning to measure. The Falkland pool will fill again tomorrow. The female orca will return, her cub will watch and practice and remember. And one day when that cub is old enough and strong enough to navigate the rocky passage alone, it will bring its own young to this same coastline. The knowledge will continue. The pool will continue to fill. And the cycle that began with one orca's discovery, one moment of innovation that became a tradition, will reach forward into a future we cannot see. This is what it means for an animal to have culture. Not fire, not language written in symbols on a page, but knowledge carried in memory, passed through relationship, across generations, in a body built for the sea. Part 5. Ice Flow Siege. The Weddell Sea in early spring is a landscape from another planet. Ice stretches to every horizon, broken into 1,000 shifting fragments by the slow violence of currents and tides. The light, when it comes, is flat and white, bounced endlessly between the ice above and the ice below until the world seems to be made entirely of glare and cold. The temperature of the water here hovers at minus 1.8 degrees Celsius, cold enough to kill a human in minutes, cold enough to turn seawater to ice, but for the salt content that keeps it just barely liquid. In this place, at the edge of what life can endure, a Weddell seal rests on a fragment of floating ice and believes itself safe. It is not wrong exactly. The ice is real. The distance to the water's edge is real. And no predator the seal has ever encountered has been able to reach it here. The logic of sitting on ice has been reliable for most of this seal's life. Ice is a barrier. Ice means safety. This is the rule. The orcas have learned to break the rule. The group that approaches this particular flow is coordinated in a way that makes the word group feel inadequate. They are operating as a single distributed intelligence, communicating through a constant exchange of clicks and calls below the threshold of what human ears can detect at this distance. There are perhaps 6 of them, surfacing and diving in near-perfect synchrony, their breath columns rising together in the flat air like smoke signals. They circle the flow, not attacking, not rushing. They look, they measure, they assess. The inspection lasts several minutes. 2 animals dive beneath the flow, checking its thickness and dimensions. This is reconnaissance, as deliberate as anything a military unit might conduct before an operation. The seal watches with rising anxiety. It stands, shifts, looks toward the open water, then back at the orcas. Every direction is occupied, every exit watched. Then the orcas line up. They position themselves in a row, 10 meters from the edge of the flow, all facing the ice. A brief pause, a held breath. Then they swim together in perfect formation, diving just before they reach the flow and pushing their bodies through the water in a synchronized surge. The wave hits the underside of the ice like a hammer. The flow shudders. Cracks appear. The seal scrambles toward the center as the edges crumble. The second wave pushes the fractured flow away from the pack ice out into the open channel. Slowly at first, then with gathering speed. The seal is now on an island, a small temporary one, surrounded by animals that collectively weigh 30,000 kilograms. The ice is still solid enough to support its weight, but there is nothing beneath the water but darkness and 6 orcas. The third wave washes over the top of the floe. The seal goes into the water. It has less than a second. It does not last that long. What strikes every researcher who has ever filmed this behavior is not the kill itself. It is the precision, the patience, and the problem-solving intelligence that precede it. These orcas have diagnosed a situation, developed a strategy, communicated it to each other, assigned roles, executed multiple coordinated movements in sequence, and adapted their approach when earlier waves produced insufficient results. They have done, in effect, what engineers do. They have solved a physical problem using tools, in this case water, that they have learned to manipulate. The ice is still glittering, the sea is still flat and white, and somewhere beneath the surface, 6 orcas are feeding. This behavior was first documented systematically in the waters around the Antarctic Peninsula in the early 2000s, but it is almost certainly far older than human observation of it. Orca populations that specialize in ice floe hunting show specific adaptations. Their dorsal fins are often less dramatically tall than those of their Norwegian counterparts, a possible concession to life among ice, where a towering fin could snag overhead obstructions. Their teeth show wear patterns consistent with working in areas where ice fragments are frequent. What makes the wave wash technique particularly revealing is the evidence it provides for active teaching within orca culture. Researchers have observed juvenile animals at floe hunting events from a very young age, not striking, not leading, but present and watching. One documented calf positioned itself incorrectly on its first attempt, generating a wave that pushed the floe the wrong way. Its mother moved without aggression, simply repositioning herself to compensate, correcting the outcome. The next time the calf positioned correctly, there is a word for what the mother did. It is called teaching. The Weddell seal, bobbing in the dark water after the wave has swept it from its ice, has no knowledge of any of this. It knows only the cold, in the dark, and the shapes converging in the water around it. That is all it needs to know. The orcas are already there. Part 6, the smartest animals in the ocean. The water in the research pool is still and clear, and for a moment everything is exactly as the scientists planned it. The device sits on the bottom, a simple mechanism, a nozzle connected to a pump, designed to release compressed air in a precise, controlled pulse. When triggered, it produces something remarkable. A ring of air, a perfect torus of bubbles that rises through the water, spinning on its own axis, maintaining its shape as it climbs toward the surface. The rings are beautiful in a purely physical sense. Mathematics made visible, fluid dynamics you can see. The scientists placed the device here to study how dolphins react to novel stimuli. They expected curiosity. They expected investigation. They did not expect what happened next. A young dolphin noticed the device before the experiment officially began. This in itself should have been a clue. The animal had been observing the researchers as they set up the equipment, tracking their movements with those large, dark, expressive eyes, watching hands and tools with the same focused attention that a child might bring to watching an adult perform an unfamiliar task. When the researchers left the pool area and the pump activated for the first test, the young dolphin was already positioned above the nozzle. The first ring rose. The dolphin watched it climb, spinning perfect, rising through the clear water. Then the dolphin did something that stopped the research team cold. It touched the ring, not with its rostrum, not by accident, deliberately, with the very tip of its snout, making contact with the spinning torus of air and deflecting its path. The ring wobbled, reformed, continued upward. The dolphin followed it, watching. When it reached the surface and dissolved, the animal hung in the water for a moment, completely still. Then it turned back toward the nozzle. What followed over the next hours can only be described as play. Not the random, undirected activity of an animal passing time, but structured, experimental, purposeful engagement with a phenomenon the dolphin did not fully understand and wanted to understand better. It triggered the pump itself, bumping the activation mechanism, and watched the ring form. It positioned itself at different distances to observe from different angles. It tapped the ring from below, from the side, from above, each time observing how the structure responded to contact. It was, in the most essential sense of the word, experimenting. By the afternoon of the first day, the other dolphins in the pool had joined in. But the sequence in which they did so is as interesting as the play itself. The older, more dominant animals did not lead the investigation. They hung back, watching the younger dolphin with that familiar mixture of skepticism and fascination that characterizes any social group encountering a new behavior. It was only when a second young animal approached the device, following the example of the first, that the rest of the group began to take interest. Bottlenose dolphins, Tursiops truncatus, possess one of the highest brain-to-body mass ratios of any animal on Earth. Their neocortex, the region associated with complex thought, social cognition, and self-awareness, is proportionally larger than that of great apes. MRI studies of dolphin brains have revealed a level of structural complexity that places them in a category shared by only a handful of species: humans, great apes, elephants, and cetaceans. They pass the mirror self-recognition test, demonstrating an awareness of their own physical existence. They use signature whistles, individual calls that function like names, to address specific members of their social group. In the pool, the dolphins had developed a repertoire of air ring interactions within days. They would hit the ring with their tail flukes to accelerate its spin. They would bite at it gently, watching how the air dispersed and reformed. Two animals would sometimes work a single ring together, one striking it from below, while the other waited above to catch the reformed torus. The behavior had become, in a matter of days, a shared cultural activity, something the group did together, something that was taught through demonstration and learned through participation. The researchers noticed something else. When a dolphin created an unusually large or stable ring, the others responded differently, approaching more closely, watching more intently. The dolphin that had made the ring hovered near the dissipating torus and then descended to create another. This is play in the deepest sense, the kind that humans engage in when they perform for an audience, when they discover pride. The dolphins were not just enjoying the rings, they were enjoying each other's enjoyment of them. This is what intelligence looks like when it operates in water instead of air. Not a face that resembles ours, not hands that manipulate tools the way ours do, but a mind that encounters novelty and responds with curiosity, with investigation, with the determination to understand. A mind that shares discoveries with others, a mind that plays, a mind that performs and watches and wonders. Part 7, the Mudflat Masters. The tide is going out, and the mudflats of Laguna in southern Brazil are emerging from the water like the slow revelation of a secret. For most of the year, this stretch of estuary is simply water, brown, brackish, unremarkable from the air. But in the hours when the tide retreats, the landscape transforms. Hundreds of meters of gently sloping, silt-laden shoreline appear from beneath the surface, glistening in the subtropical sun, steaming slightly in the humid air, alive with the small creatures that live in the rich sediment beneath. Mullet, the sleek, fast-moving fish that populate these shallows, find themselves in increasingly shallow water as the tide drops, compressed toward the shore, with nowhere to go but the thin silver film of water that remains on the mud. The local dolphins have been watching the tide for generations. These animals, a resident population of bottlenose dolphins that has lived in this estuary for as long as the fishing community of Laguna can remember, have developed a hunting technique that exists nowhere else on Earth. It was not taught to them by researchers. It was not developed in captivity. It evolved here in this specific estuary in response to this specific prey through a process of cultural transmission that began with a single innovative individual and spread gradually through the social network of the pod. Today, it is the defining characteristic of this population. It is, by every definition of the word, a local tradition. The dolphins position themselves parallel to the shore, in water perhaps a meter deep, facing a school of mullet that has been herded against the shallows. And then, in a movement so sudden and so precisely coordinated that it is almost impossible to believe it is not rehearsed, they charge, not toward the fish, toward the shore. They drive the school from the water side, their bodies creating a wall of turbulence and pressure that the mullet cannot penetrate. The fish, panicking, have one option: forward, and forward is land. The mullet beach themselves. It is not quite voluntary and it is not quite accidental. The wave of water pushed ahead of the charging dolphins carries the fish onto the mud with enough force to strand them meters from the waterline. They thrash, they flip, they gill-breathe in air for the brief seconds before asphyxiation begins. They are completely, helplessly available. The dolphins follow the wave onto the mud. This is the extraordinary part. These animals, whose entire physiology is built for life in water, whose skin dries and cracks when exposed to air, whose bodies bear the full weight of gravity when unsupported by water, deliberately strand themselves partially to reach the beached fish. They slide onto the mud on their sides, mouths open, picking up stranded mullet with a rapid snapping motion, then using the residual wave to wash themselves back into deeper water. The whole sequence from charge to return takes perhaps 30 seconds. Watch the fishermen of Laguna during this event, and you will see something equally remarkable. They are standing in the shallows, cast nets in hand, watching the dolphins. Not by accident, not coincidentally. The fishermen and the dolphins have been hunting together here for over 100 years. The dolphins, in driving the mullet to shore, also drive them toward the nets. The fishermen, in positioning themselves strategically, create an additional wall that prevents the mullet from escaping laterally. It is a partnership, a genuine, functional, mutually beneficial collaboration between two entirely different species, one of which has a written language, laws, and cities, and one of which lives entirely in a world of water and sound. The birds arrive last, magnificent frigate birds, with their 7-foot wingspans and hooked red bills, appear above the mudflats the moment the mullets start beaching. They dive without ceremony, plucking fish from the mud and from shallow water with precise aerial strikes, taking advantage of a hunting event they played no part in creating. They are opportunists, and they are spectacular ones, but their presence does not diminish what the dolphins have achieved. The mudflat belongs to the dolphins. The birds are merely guests. What makes the Laguna partnership especially remarkable is the signaling. Researchers report that the dolphins perform specific surface behaviors, particular roles, specific steep dives near the fishermen's positions, that function as a signal a drive is imminent. The fishermen have learned to read them precisely. When the dolphin rolls in a particular way, the nets go into the water. When it dives steeply toward the shallows, the fishermen take their positions. This is language in its most foundational form, a system of signals carrying information between two parties, coordinating their behavior, refined over generations by mutual reinforcement. The dolphins that signaled effectively ate more. The fishermen who read the signals accurately caught more. The partnership deepened because it worked, and has been working, reliably, productively, for over a century. Part 8. The silt wall. There is a problem that every dolphin in open coastal water faces. The ocean is vast, the fish are fast. In a world without walls, without corners, without any natural feature to trap prey, the physics of pursuit hunting become brutally simple. If the fish is faster than the predator does not eat. Many of the fish dolphins pursue in open water have evolved specifically to evade, with maneuverability advantages that dolphins simply cannot match on a one-to-one basis. So the dolphins build walls, not with their bodies, with the seafloor. The technique is known to researchers as the mud ring or silt wall hunting strategy, and it has been documented in a small number of bottlenose dolphin populations that live in shallow, silt-floored coastal environments. It requires a specific combination of geography, sediment type, water clarity, and prey behavior to function. It also requires intelligence, coordination, and a level of spatial reasoning that, when you watch it happen for the first time, genuinely stops thought. A single dolphin descends to the seafloor in shallow coastal water, perhaps 3 to 5 meters deep. It does not descend gently. It drives its rostrum into the silt, and then, using powerful strokes of its tail and the forward momentum of its body, It begins to swim in a tight circle just above the bottom. The silt, disturbed by the turbulence, billows upward in a dense, opaque cloud. The dolphin maintains its circular path, constantly stirring, the circle gradually tightening, the silt rising in a vertical wall around it. From above, the effect is startling, a perfect ring of brown, cloudy water rising from the floor to the surface, enclosing a column of space perhaps 10 meters in diameter. Inside that column, the fish that were caught within the circle when it formed are now trapped. The silt wall is not solid. Fish could swim through it if they could see it. But the silt is so dense, the visibility within the cloud so close to zero, that the fish cannot determine where the edge of the trap is. They circle inside the column, panicking, their escape responses firing repeatedly and finding nothing to escape toward. The wall looks the same in every direction. There is no gap they can identify. And so they do the one thing that trapped, panicking fish always eventually do. They leap. The fish break the surface inside the ring, jumping in arcs of desperation that carry them out of the water and, if the dolphins have positioned themselves correctly, directly into the waiting jaws of the hunters. The dolphins know this is coming. They have positioned themselves around the outside of the silt ring at the surface, their rostrums angled inward, their bodies moving with that slow, watchful patience of predators who have already done the work and are now simply waiting for physics to complete its task. When the fish jump, the dolphins snap. Not lunging, not chasing, simply opening their mouths at the right moment, in the right place, as the fish arrive in the air and fall back toward the water. The energy expenditure is minimal. The return is enormous. There is a kind of genius in this that transcends the word hunting. What the dolphin has done is to manufacture an environment. It has taken an open, featureless seafloor and built, from nothing but silt and movement, a structure, a functional trap, that changes the behavior of its prey in a predictable and exploitable way. It has converted the physics of panic into a delivery mechanism. It has built a net without hands, without tools, without anything except understanding. Scientists call this physical cognition, the ability to understand and manipulate properties of the world, mass, momentum, opacity, fluid behavior. For a long time, it was considered exclusive to humans and perhaps great apes. The dolphins of the coastal shallows have been quietly demonstrating otherwise for thousands of years. We have moved through the cold of Norwegian fjords, the wind-torn Falkland coastline, the crushing silence of Antarctic ice, and the warm shallows of Brazilian estuaries. In each of these places, the same truth surfaces. The ocean is not a simple place, and its creatures are not simple. They plan. They teach, they remember and innovate, they form cultures, pass knowledge across generations, and play. They have, in the fullest sense of the word, lifies. The question is not whether these animals are intelligent. The evidence is overwhelming. The question is what we intend to do with that knowledge. What do we owe creatures that think, that grieve, that teach their young and mourn their dead? How should cetacean cognition change the way we treat the ocean, manage its fisheries, address the warming of waters that are, for these animals, not habitat but home? Tell us in the comments, which of these hunting strategies left you most astonished, and why? Was it the architectural precision of the carousel hunt, the courage of the female orca entering the Falkland Passage with her cub at her side, the ancient partnership between dolphins and fishermen in Laguna, or the quiet genius of an animal building a wall from silt and patience alone? Your answer matters, because it tells us something about what we value and what we are still willing to protect. The ocean is out there, and it is watching back.